Welcome to our world.
We're all spheres. Our shape enables us to move effortlessly.
And land easy.
Is that why I'm kicked around? It's me, your good old pal Earth. Even I'm a sphere.
Welcome to the lesson on sphere and hemisphere. At the end of the lesson, you will be able to identify a sphere and hemisphere. You will also be able to calculate the surface area and volume of a sphere and hemisphere. So, what is a sphere? A sphere is a three-dimensional figure made up of points that are equidistant from a given point. It is an object which is round in shape. It does not have an edge or a vertex. The surface of a sphere is uniform and smooth. Before we learn the mathematical properties of a sphere, let's understand a few fundamentals. The center of a sphere is a point which is equidistant from all the points on a sphere. The distance between the center and any point on the surface of the sphere is called the radius of a sphere. The radius is denoted by the letter r. A line passing through the center and joining two points on the opposite sides of a sphere is called the diameter of the sphere. The diameter is equal to twice the radius. It is denoted by the letter d. Now let's learn about the surface area of a sphere. The surface area of a sphere is the total exposed area of the sphere. Let's understand this further. Observe the sphere carefully. Let's draw a line on the sphere from one point to another on the opposite side. We will paint from one side of the line to the other side. Now, the whole painted area of the sphere represents the surface area. An example that will help to easily visualize the surface area is an orange. If you peel off the skin of an orange, the area of the skin represents the surface area of the orange. Is there a way in which we can calculate the surface area of the sphere mathematically? Yes, we can find it by using the surface area formula. If we have a sphere of radius r, we can calculate the surface area by using the formula A is equal to 4 pi r squared. You can observe that the surface area is equal to the sum of areas of four circles having radius r. Next, we learn about the volume of a sphere. What do we mean by the volume of a sphere? The space occupied by the sphere in space is the volume of the sphere. In order to understand the concept of volume better, let us perform an experiment involving two balls. See the two balls. Can you see that the volume of the red ball is exactly half of the volume of the blue ball? Let's try out an experiment. Here are two containers of same size, filled with water to the brim. Immerse the red ball completely in the container. As you can see, the water overflows. Let's collect the water and keep it aside. Then, immerse the blue ball completely in the other container. Collect the water. On comparing the quantity of water in the two measuring jars, we find that the quantity of water that is in the right jar is exactly half of the quantity that is in the left jar. So, we can say that the volume of the red ball is half the volume of the blue ball. Now, let's find a way to calculate the volume of a sphere mathematically. The mathematical formula to calculate the volume of a sphere is 4 by 3 pi r cubed. If you know the radius of a sphere, we can use this formula to calculate the volume. Then, we can calculate the volume of the balls or any sphere without performing an experiment every time. Okay, is there anything left to learn? Yes, we have to learn about the hemisphere. A hemisphere looks like this. How is a hemisphere obtained? Here is the procedure. Take a sphere and cut it into half. The sphere gets divided into two equal parts. Each part is called a hemisphere. A hemisphere has two faces, a flat surface which is called the base and a curved surface. Now, let's calculate the total surface area of the hemisphere. The total surface area of a hemisphere is the sum of the areas of the curved surface and of the flat surface. The surface area of the curved surface is exactly half of the surface area of the sphere, that is, 2 pi r squared. The flat surface resembles a circle, for which the area is equal to pi r squared. Therefore, the total surface area of a hemisphere is the sum of the areas of the curved surface and the flat surface, that is 3 pi r squared. You can observe that the surface area is equal to the sum of the areas of 3 circles of radius r. Now, let's calculate the volume of the hemisphere. Since the hemisphere is exactly half of the sphere, it follows directly that the volume is half the volume of the sphere, that is 2 by 3 pi r cubed.